Hello everyone. So in this video we will discuss that how we can delete the first node of a singly linked list. So let's see the code and its working step by step using an animation. So here you can see that let's say we are given a singly linked list having 3 nodes with data is 10, 1 and 11 where head is pointing to the first node, and let's say in our singly linked list class we have created this head as an instance variable, and we have written one of the method in that class which will manipulate this singly linked list. So here you can see that this is the code to delete the first element of the singly linked list. So let's see the demonstration of this method, that how it manipulates this singly linked list and deletes the first node. So when we call delete first method, you can see it has a return type of list node. So what it will do, it will delete the first node and it will return from this method. So when we call delete first, the first step we check is whether head is equal to null or not. Because if head is equal to null, it means head is pointing to null and there are no nodes to delete. So we simply return null. So currently you can see that head is pointing to a node having value as 10. So therefore this condition comes out to be false. And the execution point reaches here. Now here what we do is, we create a temporary variable which will also point to the first node of the singly linked list, because head is always pointing to the first node. Now why we are creating this temporary variable is because when we delete this node, we need to return it from this method. So we are creating this temporary variable of type list node, and whatever the reference value head is holding, we are simply assigning it to the temporary variable. So as head is pointing to this first node, after this assignment there will be a temporary list node which will also point to this node. Moving ahead, now as the temporary list node is pointing to the first node of the singly linked list, after its deletion the linked list will have only 2 nodes, and head should point to the second node now, because when we delete the first node, the linked list remains with the 2 nodes and the second node becomes our new head. So we need to traverse this head to the second node. So how we will do that? We'll simply assign the value head.next to head. So head is pointing to this node, its next is pointing to the second node. So once we assign head.next to head, it would look something like this. That now head has simply traversed to the second node, and as head has traversed the second node, we can safely delete this first node. Moving ahead, so here you can see that head is pointing now to the second node, and this will be our newly singly linked list because we have deleted the first node. But if we return this temporary list node directly from this method, these 2 nodes will also get returned along with this temporary list node, because there is still a linkage here. So what we do is, in order to break this linkage, we simply assign null value to temp next. So temp is pointing to this node and its next is pointing to the second node. So we need to break this linkage. So after assigning null, it would look something like this. You can see we have completely separated the first node from the singly linked list. So at the last step, we simply return this temporary list node. And after deletion of the first node, now our linked list has only 2 nodes with a new head pointing to the second node, which has now become the first node of the singly linked list. So friends, let's say if you want to perform delete first again. So we call delete first again on this singly linked list having 2 nodes. So it would look something like this. We check whether head is equal to null or not. So head is pointing to this node, therefore condition in if block comes out to be false. We again create a temporary list node which will point to the first node of the singly linked list, because we are assigning the value of head to it. After assigning this value, we simply traverse head from this node to its next because we want to delete this node. So by assigning head dot next to head, head will not point to the second node of the singly linked list. Then we'll simply break this linkage here by assigning null value to temp's next. And finally we'll return the temp. So now our singly linked list has only one element. So by calling this delete first 2 times, we have deleted 2 nodes which were at the beginning of the singly linked list. So let's say we want to delete this node also. So we'll call delete first again. We check whether head is equal to null or not. So here head is pointing to this node, therefore it's not equal to null. So this condition comes out to be false. We create a temporary list node pointing to head, something like this. And then we'll simply traverse head to its next because we want to delete this node. So by assigning the value head dot next to head, what will happen? Head is pointing to this node and its next is pointing to null because this is the only node left in our singly linked list. So now head will point to its next, which is null. We simply assign null to temp dot next to break this linkage. But as it is already pointing to null, it would look something like this. And we can return this temporary node because we have deleted it completely. So now our singly linked list has no elements and head is pointing to null. So if we call delete first again, we first check whether head is equal to null or not. So here you can see now head is equal to null. So therefore this condition comes out to be true. And as there are no nodes left to be deleted, we simply return null. So friends, this was the algorithm to delete the first node of a singly linked list. We saw that singly linked list had 3 elements at the start. We called this method delete first 4 times to delete all the nodes from the singly linked list. So now let's go to Eclipse and see the demonstration of this algorithm step by step. I hope you like this video. Thanks, have a nice day.